Hello, class. We're about to start the second part of lesson 6. Now, with the second part of lesson 6, we're going to deal with the volume of pyramids and cones. So, this is actually on page 400 in your textbook. So, let's get started. A pyramid is a three-dimensional object with four triangle faces that connect to the same vertex. The base of a pyramid can be any closed figure, but the pyramids that you will see on the GED mathematical reasoning test will all have square bases. The rectangular prism and the pyramid shown here both have identical square bases and the same height. Compare the two figures. As you can see, the pyramid holds much less than a rectangular prism. In fact, it holds only 1/3 of the rectangular prism's volume. The formula for finding the volume of a pyramid is as written below. Notice that B equals the area of the square base. The height of a pyramid is the perpendicular distance from the base to the vertex at the top. So the volume is equal to 1/3 times the base times the height. Now, what I want to do, I'm going to alter this formula a little bit like I did with the rectangular prism. Now, if you don't remember, I will write out what I had with the rectangular prism. Now, with the rectangle, I did the volume. Now, this is for the rectangle, was length times width times height. This was the volume of a rectangular prism. Now I'm going to change the volume of the square pyramid to 1/3 times the length times the width times the height. So I think this would be a little easier to remember. You may want to write this down, but this is the alternative to the 1/3 times base times height. So it's 1/3 times the length times the width times the height. Okay, so now we're going to scroll down and we're going to go here to, matter of fact, let me just make sure one thing here. Yeah, we do have the volume of a cone too. It says a cone is similar to a cylinder. Both have a circular base and a curved side. The curved side of a cone slants inward, so it means at a point or vertex. The volume of a cone is 1/3 of the volume of a cylinder with the same size, base, and height. So on the GED formula sheet, notice that the formula for the volume of a cone contains the formula for finding the area of a circle. So basically, the volume of a cone is this 1/3 times pi times radius squared times height, which we have here. So now, we go here to 6.2. Now it says find the volume of each object to the nearest unit. So with that being said, and I guess I should have said this as well, if you don't see it in your book, you can write down the volume of the cone so you will have it readily accessible to you as you're doing the problems. So the volume of a cone again is 1/3 times pi times radius squared times the height. So now we're going to go through and do these problems here. So let's start with problem number 1. Now, problem number 1, we have the volume of a pyramid. So we know the volume of a pyramid is 1/3 times length times width times height. So now we have the volume of 1/3. The length is 3 and the width is 3. And the height here is also 3. So yeah, the volume of this would be 1/3 times 3 times 3 times 3 is 27. So 1/3 times 27, we could put that in our calculator. So we could put N over D, which will give us 1/3. We'll put 1, down arrow 3, and then a right arrow. Then we could do the open parenthesis, 27, and then press enter. So our answer here is 9. So the volume is actually 9, and here we had inches, so it's 9 cubic inches. 9 inches to the third power. So the volume is 9 cubic inches. All right, now we move on to problem number 2. Now, if you notice here, we have a cone. So with the cone, remember the volume is equal to 1/3 times pi radius squared times the height. All right, remember this is problem number 2. Okay, so now volume is equal to 1/3. Pi we'll rewrite as 3.14, the approximation, and then the radius. Now remember, this line here covers all of the circular bottom of the cone. So we have to take half of this. Half of 9 is, we could just put 9/2. So that would be the radius squared. And then the height is 6. So now we have a volume is equal to, we could put this in our calculator. We would type in N/D, which would be 1, down arrow 3, and then the right arrow. Then we have parenthesis 3.14. Close the parenthesis, open the parenthesis. The radius, we'll hit N/D, is 9, down arrow 2, right arrow, we'll close our parenthesis, and then we would take this parenthesis to the second power, and then parenthesis 6. And we'll press enter. So our final answer here will be the volume, and they tell us to round to the nearest unit, so that means to the nearest whole number, so it'd be 127 inches cubed. So that would be the answer for number 2. Now number 3, if you look here at number 3, is still a cylinder. So what I'm going to do, I'm just going to do, well, I guess I could do all of them. Okay, so the next problem, number 3. Same thing, we had a volume is equal to 1/3 times pi radius squared times the height. So the volume is 1/3, pi is 3.14. The radius, they give us the radius because you notice this is half of the circular bottom of the cone. So that'll be 5 and squared, and the height here is 12. So now we will put this in our calculator. We'll press N/D, 1, down arrow 3. We have our right arrow, parenthesis 3.14. Close the parenthesis, open parenthesis 5, close the parenthesis, x squared, open parenthesis 12, close that parenthesis and press enter. So it gives us 314, and I believe that was centimeters. Yes, so it'd be centimeters cubed. So it'd be 314 centimeters cubed. So now we go down here to problem number 4. Now we notice here we have a pyramid. So the volume is equal to 1/3 times length times width times height. So now we have the volume is equal to, now the length and the width is 12. So the volume is 1/3 times 12 times 12, and the height is 10. All right. So now what we would do, we will put this in our calculator. Okay. So then we hit N/D, 1 at the top, 3 on the bottom, right arrow, open parenthesis, we have 12, close our parenthesis, another open parenthesis of 12, close our parenthesis, open our parenthesis, 10, close our parenthesis and press enter. So it's 480, and let's see what the units are. The units are meters, so it'd be cubic meters. So that would be our answer for number 4. All right. So number 5, you notice here with number 5, we still have the pyramid. It just looks a little different, but it's still a pyramid nonetheless. So volume is equal to 1/3 times length times width times height. Volume is 1/3. The length is 2. The width is 2. And the height is 8. So the volume is equal to 1/3. Now 2 times 2 is 4 times 8 is 32. So we could multiply that out by hand, or you could type all that in a calculator. But I'm just going to do this here. So it's 1/3, right arrow, open parenthesis, 32. Close the parenthesis, press enter. Now if you notice, it gave me a fraction, so you'll press this arrow key, and then we'll round to the nearest whole number, so it'll be 11. And that would be 11 inches, 11 cubic inches. So now, we move on to problem 6. Now if you notice here with problem 6, it is still a cone. So we'll do it the same way we did the other cone problem. So we got number 6, the volume is equal to 1/3 times pi squared, pi radius squared height. Okay, so we had a volume is equal to 1/3, pi is 3.14. Now the radius, if you notice here, this is the diameter, so we take half of that, which we know would be 15/2, and we square it. And the height is 18. Now we can put this right in our calculator. Clear this out. We could do N/D, 1 at the top, down arrow, 3 at the bottom, right arrow. Then we would do the open parenthesis, 3.14. Close our parenthesis, open a parenthesis. We hit N/D. We have 15, down arrow, 2, right arrow. Oh, not right arrow. I made a mistake and pressed the parenthesis. But it was supposed to be right arrow, then the parenthesis, then the square button, and then open parenthesis 18. Close your parenthesis, press enter. So now we round to the nearest whole number. So your volume is approximately 1,060. And now we need to see the units. The units are centimeters, so it's cubic centimeters. So that is your final answer. Now that took care of problems 1 through 6. So now we have 4 more problems to go. So we have 7, 8, 9, and 10. So let's get to it. Okay, so it says for B, it says choose the one best answer to each question. So number 7, it says advertisers have designed a pyramid-shaped package to hold action figures. Now, as you see, we have this pyramid shape. Okay, so now with that being said, we would say after testing the design, the manufacturer decides to increase both the length and width of the base by 4 centimeters. How many more cubic centimeters will the new package hold than the package shown above? All right. So with that being said, first of all, we need to know how much that first package has. So the volume is equal to 1/3 times length times width times height. So volume is equal to 1/3, the length is 10, the width is 10, and the height is 15. So the volume is 1/3 well, let me just multiply this out. We can put this in our calculator now. All right, so we'll press N over D, have 1, down arrow 3, right arrow. Then we have parenthesis 10, parenthesis 10, parenthesis 15, press enter. So then this volume is 500. So now we had a volume at 500 cubic centimeters. Now that's what we had originally. Now we're going for the new value. Now remember, they said that the base or the length and width increased by 4 centimeters. So that means instead of 10, it'll be 14. And the height will remain the same. Because remember, they said each one increased by 4 centimeters. So yeah, well, I did it again. We could put this in a calculator. Now, let's see. I want to experiment something here. Oh, that didn't do anything. Okay, so we would do N over D. So 1, down arrow 3, right arrow, open parenthesis, 14, close the parenthesis, open parenthesis, 14, open parenthesis, and then it'll be 15. And we'll press enter. So then the volume is approximately 980. Let me rewrite this, because I had made a mistake and was rewriting a problem. So we really don't need this here. Okay, so now, this is the new amount, this is the old amount. Now remember, they asked us to find out how many more cubic centimeters would a new package hold. So then we would do subtraction. We'd do 980 cubic centimeters minus 500 cubic centimeters. So it'll be 400 cubic centimeters. So I'm sorry, it should be 480, not 400. So it'd be 480 cubic centimeters, which is A. So that would take care of problem number 7. Now problem number 8, it says the height of a cone is half the diameter of its base. If the cone's height is 4 inches, what is the cone's volume to the nearest cubic inch? So first of all, let's take a look here at number 8. Let's write what we have. The height is 4 inches. Now they tell us that the height of a cone is half the diameter. So we know half the diameter is the radius. So that means that the radius is equal to 4. Because it says it's half the diameter and the height is 4 inches, so that means the radius is 4 inches. Okay, now they want to find the cone's volume. Now remember, the volume of a cone is 1/3 times pi radius squared height. Now that is why I wrote down the radius instead of the diameter. So now we have the volume is equal to 1/3, pi is 3.14, the radius is 4, and the height is 4. Now we could put this in our calculator because they want to find the volume. So we'll press N over D, 1, down arrow 3, right arrow, we have parenthesis 3.14, and then we will have parenthesis 4, then we will square it, open parenthesis 4, close the parenthesis, press enter. So that would give us approximately for the volume 67 cubic inches. So that would be the answer, and that would be C. Okay, class, starting with number 9. Okay, we need to find the volume of both of these figures because I notice here that all the answers depend on the volume of each. So we have the volume of a rectangular prism, which is just length times width times height. And then we have the volume of a triangular prism, which we know is 1/3 times the length times the width times the height. So let's compare the two. So the rectangular prism, we got the length of 4, width of 3, height of 2. So the volume is equal to 24 cubic centimeters. So that took care of the rectangular prism. Now we do the triangular prism. So we have 1/3 times the length is 3, the width is 3, and the height is 6. Now if you put this in your calculator, you would get 18, and that'll be cubic centimeters. Okay, so with these two, now we can compare this. The volume of figure A equals the volume of figure B. We know that's not true. So let me put this here. This is figure A, and then I'll put this as figure B, so we'll know the difference. The volume of figure B is greater than the volume of figure A. We know that's not true. Both figures A and B have a volume greater than 20 cubic centimeters. That's not true because figure B doesn't have it. And then D, the volume of figure B is less than the volume of figure A. So we know our answer here would be D. Okay, now we go to 10. A cone's base is a circle with the radius of 8 inches. The cone's height is 15 inches. What is the cone approximate volume in cubic inches? Okay, so for number 10, we have to do the volume of a cone with a circular base. So it'll be 1/3 times pi radius squared height. So we have 1/3, pi is 3.14, and they tell us that the radius is 8 inches. So it'll be 8 in parentheses squared, and they give us the height at 15. So now we can put this in our calculator. So we have N over D, 1 in the numerator, 3 in the denominator, right arrow, parenthesis, 3.14, close the parenthesis, open the parenthesis, we have 8, close parenthesis, then we have to square that 8, then parenthesis 15, close that parenthesis, press enter, and they told us to round to the nearest, what was that, nearest cubic inch. So it'd be 1005 cubic inches. So our answer here would be, that's interesting. So the answer is 1005, but we will have to pick the best answer, which would be D. So that would be our final answer. Now this is good because, like I always tell you, with the choose the one best answer to each question, we notice that these two are not the same, but the 1000 is closer than any of the other values, so that is why it's D. Now we are done with this lesson. I will upload this to YouTube. Have a wonderful day.